This is a demonstration video of Skyscraper running on macOS 15 on the ARM architecture. So it's very good for seeing how the overall system operates and how the sim engines work internally and other things. So you might find it very interesting to see this. As you can see, I stopped it in the main function, the entry pointed into the application. This shows the CPU registers. And now we're running the application, and we run other buildings. The new city demonstration. So as this loads, we can actually go back and start reviewing some of the code. Now Skyscraper's finished running and finished loading, I mean. Now if you can see this has around 35 sim engines running in parallel at the same time. So when we break back into the debugger, it'll actually show each of the sim engines. You can actually switch between the sim engines, view the internals of each one and everything. So now we're going into the master run loop. This is at the very top of the program. Now we're reviewing the virtual manager source code and looking for its run function. So we added a breakpoint there, and we continue the program so it stops there. Now currently it was stopped at run engines, so now we're going inside run engines. This function runs each of the engines in like a kind of like a hypervisor. So each engine is like a client of the system. So now we're running into the main engine context run loop function, and now it goes into the script processor, the script interpreter. I've considered the virtual manager to be a nanokernel because it includes a hardware abstraction layer and other things. What we're looking for is the master SBS run loop. So we actually found it. It's right there, so we put a breakpoint on it. And then we go inside it. So now this is inside the sim engine itself, running all the just the different management functions, like camera synchronization and, you know, now we're looking at the hardware abstraction layer code. This is the rendering code for the Ogre 3D rendering engine. That line just simply tells Ogre to run a single frame in 3D. So now we're continuing the program, and now it's running normally, so we'll do a little bit more here. Now we're launching the simple building. We're going to launch it directly in front of us, and currently I'm looking at the just different engines so I can figure out where to place it in 3D space. We're going to put that one at x300. And then we add bounds just to cut around the building. It'll do it automatically for at least that one, but we'll do it manually for this one. Then click load. It's running a little slower because it's running under a debugger right now, so it's in debug mode. Here's the new building that was created, so we loaded it from the file and it basically did a procedural load to create it in 3D space. So now we can just look at it a little bit and turn around. So there it is, engine index 35, so it's engine number 36. Now we're rotating it around a little bit so you can basically see that you can manipulate and manage each sim engine independently from the rest of the environment. The ground got a little messed up there. So there's the building. Now we're going to shut it down. And once the simulation basically reconverges, it'll just simply disappear. So it does a cascade delete on the objects, and then everything just is removed from the simulation. So now we're going to, I noticed the Northeast Trad Convention Center building over there. So now we're going to move it around a little bit. You can also move sim engines vertically. Now I click Set Active and it'll jump to the camera that's inside the Northeast Triad Convention Center right now. So it's a separate, each sim engine runs its own camera, and it basically hands off the camera to each simulation, each sim engine. Now we're going to look at the engine context source code, and we're going to take a look at the description of it in the header file. Now we're looking at the unload sim function. So what we're going to do is we're going to unload one of the simulators and watch it actually unload in this. So I'm going to put a breakpoint in the beginning of unload sim. Then we go back in and we shut down Northeast Triad Convention Center. Now what I'm doing is going up the call stack so you can see the other, where it's been called from. Now let's see this actually run. So it already deleted the sim engine instance. Now it's resetting itself and then it exits. Now you'll see that slot 4 is empty. Now we're going to load the Sky 1 building. we're going to see where this is supposed to be positioned, so I think it's -2000. It runs a little faster if you turn off cut external and cut floors. Let's change these to 500 and 5000 vertical. One of the features in here that I don't think I documented yet is that when you choose an engine in here and click load building, it'll create that new building as a child of the engine that you selected, so it creates a hierarchy of buildings essentially. Now we're inside the script interpreter, and so we're going to put a breakpoint at the add floor command. We're in the floors section right now, and it's not responding to that, so we're going to probably try to use add wall instead. So now it immediately stopped at the add wall function. You can see what the line data variable has. I'm going to run this function again because it's skipped. So we do run to cursor, and then we the dereferencing kind of shows a few other functions there. There's the add wall command that we're trying to see. This function's getting the floor base. And now we go into add wall main, which is the primary, basically core add wall function in the simulator. So it'll go down and, you know, adjust the wall width and height and everything, and textures and other things. Now at the bottom of this is wall object add quad. A quad is a 3D rectangle. It's probably one of the simplest objects that you can actually create. The add quad function creates a vertices polyarray. You can so you can see the vertices within the array itself. And vertices is a standard library vector. Now we're inside the create mesh function in the polymesh geometry processor. What this thing does is this is responsible for generating almost all the 3D geometry that you actually see in the simulator. It goes into the second create mesh function, which is a more advanced internal function for creating things like the object plane and the triangulation of the quad. So it actually generates triangles for this. After create mesh, we go down to where it creates a new polygon object. And now add quad is finished. And it returns the wall object that it created. So it created a wall object in the function, and it stores the command in the simulator of where, like what script code line and everything of where it created the wall. Now we're going back through the script interpreter through the general functions. Now we're back in the run engines function, which is kind of sort of like the hypervisor of the system. I've called it a nanokernel because it includes a hardware abstraction layer in a separate component. Now here's the Sky 1 building running. If we look up, it has over 330 floors. And now it's running in slot 4, so the system found that slot 4 was empty and filled it with this building. Now again, we can raise it up and down. I'm going to change this to 10 so it'll go faster. That's the Sandy Spire building over there. Now we're going to initiate a shutdown for that, for the Sky 1 building, so it'll take a little bit. There we go. Slot 4 is empty again. This is called binoculars mode, so press the B key and it'll zoom in. It changes the field of view with the FOV. Anyway, thank you for watching. I'll be putting up some more videos eventually.